and gentlemen, my name is Dr. John Belkowitz. I'm the Director of Research Development, Intelligent Concrete, and it's Math Monday, sponsored for you today by the whale shark, which I guess really isn't a shark. So the whale shark is a shark. It's actually one of the slowest moving sharks and one of the largest extent fish species, measuring up to 18.8 meter long. Thanks for sponsoring us today, whale shark. You're awesome. So today we're talking about segregation using a high-range water reducer. We're getting into the meat of what happened with our glow-in-the-dark concrete sample that, ding, Patchouli is showing you now. Patchouli, can you do that? Mm-hmm. You're awesome, Patchouli. So what we wanted to bring up, this was a question that somebody addressed to me after seeing the videos that we did, and we'll include the link right up here. Now this is the white glow-in-the-dark concrete sample. And this was the first mix that I did where I took out my non-chloride accelerator and I was using like 2 or 3% for my mix and replacing that with the same water. The unfortunate reality is you can't just do a one-to-one replacement of that. You really need to play with the mix a little bit more, especially because we were using a very high dosage of our high-range water reducer. And that's what I wanted to talk about today. One of my buddies reached out to me and said, hey, maybe you should be using a different high-range water reducer instead of the one that you're using right now. And what that kind of implied to me was that it was the admixture's fault, when in reality it was my fault. That I was using a very high dosage of a high-range water reducer, one of the best in the industry, and going at such a high dosage can lead to a sensitivity for segregation. And that's our topic for Math Monday. What we've got here is a nice little x-axis that I played with, or x and y axis that I played with, to give you a representation of what I'm driving at here. And in our x-axis, we have our high-range water reducer dosage. Now, most good high-range water reducers have a dosage rate anywhere between 4 and let's say 10 ounces per hundredweight. Now, that doesn't mean you can't use less and more, but what we try to do is, or Patchouli drew it out, is we try to represent that if we can recognize that for most high-range water reducers, and not all high-range water reducers are created equal, but we're assuming a polycarboxylate style high-range water reducer, when we hit a dosage of 15 ounces per hundredweight, we're really maximizing that high-range water reducer and almost reaching a point of diminished return. And some could argue maybe that's a little bit too high, but I like that. I like that we're really skirting that it's already too much at this segregation zone. And what this implies is if we're in this portion, we've reached a place where the concrete is not holding that composite homogeneous structure to it, that instead of having concrete and paste all together, you have aggregate and sand on one side, paste on the other, and if we do a spread or a slump, using our slump cone and it pancakes out, we're going to see a nice halo effect and a different separation between our paste and our aggregate. That unstable zone, well, that's going to be where we haven't reached our segregation point, where we have more of a concrete that's homogeneous, but it's teetering on the edge. And as we get close to that segregation zone, the closer we get to that unstable or instability of our concrete, and anything can set it off. And then finally, that first zone, that stable zone, the lower amount of this high-range water reducer that we put in there, it should be apparent that the lower sensitivity that we have to water. A high-range water reducer, especially the ones that we're talking about, this polycarboxylate style, they have anywhere between 25 to 45% ability or water reduction ability to keep the same slump. So in putting more of that, you're increasing that concrete's mix's sensitivity to that segregation. And the way that we describe or define segregation is the actual slump slash spread over the design slash or spread slash slump or slump slash spread. So if you have a greater slump or spread than your design, then you're getting to that point of the probability, or increasing the probability of your segregation. So when it comes down to it, what I did wrong in that glow-in-the-dark sample is what we're trying to show here. If we're using the same dosage of high-range water reducer in the same mix, but increasing our water cementitious ratio, our water content, we're increasing the likelihood for segregation and even overdosage, which is that bubbling of air in a milky, white, or wax substance to the surface, and total failure of your composite. And basically that's what I did. I was using a great high range. I was using it at high water I was using it at a low water cementitious ratio to begin with, but then when I replaced that non-chloride accelerator for water, I effectively increased my water cementitious ratio, and of course the probability for segregation, and then ultimately led to even worse than segregation, the segregation and the overdosage, which is great because seeing that I understood exactly what went wrong and how to get past it, and that's what we saw in the second mix. By pulling back the water, I reduced that bubbling to the surface. Now today, or maybe tomorrow, we're going to be doing that next step glow-in-the-dark mix where we're going to be using a defoaming agent, pulling back our water even a little bit more, still keeping that fluidity and that workability and that pot life, but reducing our air bubble content significantly. So hopefully you learned something today. Let us know if you got any concrete questions, concrete concerns. Don't forget to like and subscribe. We're doing a drawing this month for a piece of glow-in-the-dark concrete. So like and share and you'll be entered into that drawing.